Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2185, indicates that the Engine Coolant Temperature, ECT Sensor 2, is experiencing a high voltage condition in its circuit. This specific DTC is crucial for maintaining proper engine temperature management, as the ECT sensor provides the engine control module, ECM, with critical temperature readings. The ECT Sensor 2 is usually located near the engine, specifically in the coolant flow path, and it plays a vital role in assessing engine temperature for efficient performance and emissions management. When this sensor malfunctions, it can lead to inaccurate readings, causing the ECM to operate inefficiently. Therefore, addressing this DTC is essential for vehicle performance and longevity. The following slides will delve deeper into the potential causes, symptoms, and troubleshooting steps necessary for resolving the issue. The ECT Sensor 2 serves an instrumental function by measuring the temperature of the engine coolant and sending this information to the Engine Control Module, ECM, located near the engine within the coolant system. This sensor helps the ECM regulate engine temperature, which aids in optimizing performance, efficiency, and emissions control. It operates by varying its resistance according to the temperature it senses. Higher temperatures lead to lower resistance, which changes the voltage the ECM reads. If the sensor presents a high voltage condition, as captured by the DTC P2185, it indicates a malfunction, potentially affecting engine performance. Proper functioning of this component is vital for accurate temperature regulation within the engine, impacting overall vehicle health. Several factors can lead to the appearance of DTC P2185. A commonly identified cause is a faulty ECT Sensor 2 itself, which may be sending erroneous voltage readings due to internal damage or defect. Additionally, open circuits or shorts in the wiring that connects the sensor to the powertrain control module, PCM, can manifest as high voltage signals. Poor connections or loose terminals at the ECT Sensor 2 or the PCM can also contribute to this issue, interrupting the signal transmission necessary for accurate readings. Each of these causes disrupts the sensor's ability to function, leading to the high voltage condition flagged by this DTC. The symptoms of a high voltage condition in the ECT Sensor 2 circuit can significantly impact vehicle operation. One of the most immediate issues is engine overheating, as the ECM might respond incorrectly to high temperature readings, leading to inadequate cooling measures. Additionally, poor fuel efficiency may occur because the engine could be operating outside its optimal temperature range, causing it to burn fuel inefficiently. Often, drivers will notice that the check engine light illuminates on the dashboard as the vehicle's onboard diagnostics flag this problematic condition. These symptoms can escalate and lead to more serious mechanical issues if not addressed promptly. The first step in troubleshooting DTC P2185 involves verifying the problem by turning the vehicle to the on mode without starting the engine. Using the Honda Diagnostic System, HDS, check the parameters associated with ECT Sensor 2, specifically monitoring the output voltage. If the reading exceeds 4.92 volts, it confirms the issue. If the current conditions match this threshold, this confirms that the fault is present. Hence, you would proceed to the next troubleshooting step. Conversely, should the conditions not align with the threshold, it indicates an intermittent issue, prompting further investigation into potential poor connections or loose terminals at the ECT sensor and the PCM. This initial verification is crucial for determining the next appropriate steps. In this second step, you will need to turn the vehicle to the off-lock mode, followed by the disconnection of the ECT Sensor 2 2P connector. This is crucial to ensure safety and prevent sensor damage during testing. Using a jumper wire connect terminals A and B of the 2P connector to mimic the ECT sensor's operational state. After making this connection, turn the vehicle to the on mode again and utilize the HDS to measure the voltage output from ECT sensor 2. If the voltage surpasses the threshold of 4.92 volts under these conditions, it indicates that the ECT sensor 2 is functioning improperly, leading you to replace the sensor. If it does not match, there may be issues elsewhere in the wiring or connections. Continuing with step 3, turn the vehicle to the off lock mode before removing the jumper wire previously used. This ensures the circuit is clear for accurate testing. After removing the jumper, turn the vehicle back to the on mode and check the voltage between the designated test points, specifically between the first connector pin of ECT sensor 2 and body ground, while the ECT sensor 2 2P connector remains disconnected. You should expect to measure a voltage near 5.0 volts. If this voltage is observed, it confirms that the TW2 sensor line is functioning correctly, allowing you to proceed to the next step for further diagnosis. If the voltage does not meet expectations, there could be an issue within the TW2 sensor line itself. In step 4, again, start with turning the vehicle to the off lock mode as a safety measure. Next, employ the HDS to short the SCS line, which disables the airbag system for safe testing. Afterward, disconnect the PCM connector A, 51P, and begin checking for continuity between test points 1 and 2, the ECT sensor 2 connector number 2, and PCM connector A, 51P, number 39. This test checks for continuity in the SG5 wire that connects the sensor to the PCM. If the continuity is confirmed, it would indicate that the wiring is intact, allowing for potential further steps like updating the PCM software or substituting a known good PCM for further testing. Failure to find continuity necessitates repairs to the SG5 wire. In the 5th and final standard troubleshooting step, similarly position the vehicle to off mode, followed by jumping the SCS line with the HDS, securing an operational testing environment. Disconnect both the PCM connector A, 51P, and the ECT sensor 2, 2P connector to allow for a clean test of continuity between respective test points. This time, focus on test points: ECT sensor 2, 2P connector number 1, and PCM connector A, 51P, number 43. Completion of this task verifies the integrity of the TW2 sensor wire that interfaces with the ECT sensor and the PCM. If continuity exists, you might consider updating the PCM software or substituting it if necessary. On the other hand, identifying a break in continuity clearly points to an issue with the TW2 wiring, calling for repairs to restore functionality. After completing the necessary repairs, it's critical to verify that the problem has been resolved. Begin by clearing the DTC P2185 from the vehicle system using the HDS. Following this, conduct a test drive of the vehicle to assess its performance under real-world conditions. During the drive, keep an eye out for any reoccurrence of the check engine light, as this would indicate a persistent issue. Observing no fault codes after the test drive suggests that the repairs were successful and that the ECT sensor 2 circuit is functioning correctly. Anchoring this verification process ensures both reliability and safety in the vehicle's operational parameters. Preventive maintenance is vital to help avoid future occurrences of DTC P2185. Regular system checks are recommended, focusing on the ECT sensor and associated wiring. This involves visually inspecting the connections to ensure they are secure and free from corrosion or damage. It's also advisable to monitor the voltage readings during routine service intervals to catch any discrepancies early. Additionally, keeping the powertrain control module (PCM) software updated ensures that the engine management system operates with the latest enhancements and fixes. Engaging in these preventive measures can enhance vehicle performance while safeguarding against unexpected sensor failures. In conclusion, understanding the role and function of the ECT Sensor 2 is essential for effectively addressing DTC P2185. This troubleshooting guide provided a comprehensive look at the steps needed to isolate and resolve issues affecting the sensor and its related circuits, emphasizing the importance of systematic testing. Each troubleshooting step builds on the results of the previous one, ensuring that no potential causes are overlooked. Additionally, integrating regular vehicle maintenance and preventive measures into your routine can significantly reduce the risk of sensor malfunctions. By adhering to these protocols, you can enhance your Honda Fit's reliability and longevity while promoting optimal operation of its engine management systems. Please like and subscribe to the channel. See you next time!